Distillation is a basic procedure. A body of water is heated until it becomes steam. The steam travels through a tube and then collects and cools in another container, where it returns to its liquid state. You could do exhaustive research to find out which threats you avoided: lead, bacteria, viruses, and more. Or you could simply enjoy knowing your water is clean enough to drink. Content Disarm and Reconstruction, or CDR, employs a similar process. To continue the analogy, in cybersecurity, our body of water is comprised of individual files, including complex file types which are particularly vulnerable to potentially malicious exploitation. With their grouped and nested components, they can be containers of malware, ready to pour out security risks the moment an associated program acts upon the file. Cybercriminals regularly exploit the necessary code execution on commonly used complex files to compromise a system. With surgical precision, however, CDR breaks the file down to its smallest components and removes any and every potential threat. Like distillation, CDR doesn't have any prejudice about identifying which contaminants are in a potential threat vector. It just eliminates them completely, and then reconstructs all the remaining pieces back into a safe and fully functional file. For example, CDR will scrub away hidden files or messages maliciously embedded within a digital photo, but the final disarmed picture looks and behaves exactly as a safe image should. When a file begins the CDR process, we don't know if it's contaminated. We just know the file is clean and working when the process is done. Microsoft Office files and PDFs are the most common file types used in the first stage of social engineering attacks. Because they can contain and execute code, these files frequently install backdoors, ransomware, bots, advanced persistent threats, or APTs, and more. The CDR process also flattens, neutralizes, and reconstructs files such as these. CDR technology can be taken even further with Deep CDR, differentiated by its recursive approach. To explain the difference, say you create a desktop folder and label it Budget. This is the capstone of a pyramid we're about to construct. In that folder, we're going to add a spreadsheet labeled Overview and another folder labeled Current Year. These two constitute the next level of our pyramid. In the Current Year folder, we add folders for Q1, Q2, Q3, and Q4, our next level down in the pyramid. Each folder gets multiple files that outline forecasts and budgets for that quarter. We can add layers indefinitely until we have built a huge pyramid with a complex structure. If this directory were zipped into a single archive and submitted for standard CDR, it would disarm and reconstruct only the capstone, nothing more. If we want to send our second layer through the process, we must manually submit those individual components, and then again, only that single layer is scrubbed. While effective, this process is not efficient. Recursion, on the other hand, works its way through layers until reaching the last. Deep CDR, in its recursive approach, would sanitize our capstone and recognize another layer is underneath. Automatically, it drops to the second level, moving laterally until that level is fully sanitized. Without need for any further user action, the process continues in a down and lateral movement, layer after layer, until the entire pyramid has been fully disarmed and perfectly reconstructed. Because of its process, CDR can only be performed on supported file types, as there needs to be a known way to reconstruct a file so that it is both safe and functional. Supported file types for CDR are continuously expanding to cover as many common use cases as possible. Importantly, CDR and Deep CDR are not intended as detection tools. It is an excellent solution to address any class of malware that we can consider an unknown threat. Its success is not measured by giving you detailed diagnostics of the contaminants left behind in the processes, but achieved through knowing your file is safe.